This conference will now be recorded.
Okay, so for example, um, let's take subcategory from a global superstore and let's take order date there. Where is order data? Right click, exact data, right click, discrete, right click, um, measure maximum. So it is having sales till 2014 only. Let's clear out. Let's place a subcategory, then order date. Okay, 12th, 15, 29, 30. So we don't have week level differences. 25th, 28th. Okay, let's do one thing. For this one, instead of greater than 8 weeks, 4 weeks, 2 weeks, and triple one, so we'll take 1 day, 2 day, 3 day. Okay. So first of all, what we need to identify? We have to identify latest order date in the business. So somewhere we wrote the latest date. What is this calculation? Max of order data. So using this, we are able to extract latest data. So obviously, what we need to find now? First, we have to find a subcategory wise latest order data. Correct? Latest data. So how to write a subcategory wise latest data? I'm writing fixed, mentioning subcategory wise max of order date. Correct? Yes, we can use this. So now what I have to do, I have to make some comparison between these two. So what is this is a classification CLF, calculated field. Okay. So how to write the calculation to make the comparison between those two? If date diff of day, what is the start date? Subcat latest date, comma, latest date. So if the date difference greater than or equal to 1, okay. So let's take less than let's take greater than or equal to 5, then top 5. Okay. Similarly, I'm writing the calculation else if greater than or equal to 4, less than or equal to 3, top 3, 2, top 2, top 1, else latest. This is my calculation. Got it? Let's drag this to the sheet. So what happened? If you look at the date based on a date difference, here I am able to find out what is top 5, what is top 4, what is top 1, what is latest. So if you look at let me remove this. Okay, like this the way I have the data. So what I expected, I want to see subcategories count for that. Pro subcategory, right click on it, make it a distinct count. Let's take classification CLF. If you look at so this is a count. 5 plus 4 9 plus 2, 5 plus 4 9 plus 2 11 plus 6 17 subcategories. Okay, so this is the count of hmm. So this is a subcategories count based on their latest order dates. So what I requested here in the scenario case, so based on the weeks I said. So usually in the business we will see a lot of difference between latest order in the business to the latest order of the respective product or respective customer. Accordingly, we are trying to segregate or classify the list. Here we have taken the reference of subcategory. So we want to classify what all are the subcategories part of greater than 8 weeks, more than 4 weeks of sales, more than 2 weeks, more than triple 1 days of sales when compared with the latest business date in the business. Got it? So accordingly, we did this calculation to classify the subcategories. As we don't have that much date differences, we have gone with the day differences: 5 days, 4 days, 3 days, 2 days, 1 day. Got it? So and also you can make this as a order of operations. mm, Default properties, sort, alphabetic, not manual. So what is latest? Let's move it. Okay. So if you look at like this, the way we have arranged the order. What is top five more than I mean this is subcategories. There are six subcategories which does not have the sale more than 5 days. Got it? So it is more than 2 days, more than 1 day. This is the latest. I mean the current orders are presented or equal to the latest date in the business. Okay, like this the way we can write a comparison to identify the latest order to latest date, latest order in the business comparisons. Okay, so let's move to the data blending. Okay, so what is a data blending? What we discussed. So blending data from multiple data sources onto the single sheet can be called as data blending. So we are pulling data from two different data sources. One is CSV file, one is a Excel sheet. Got it? So when we are doing the data blending, what is the minimum requirement to perform the data blending? At least one column need to be present in both the data sources. As we when we are making the relationship between these two, Tableau does not dynamically identify to what is the relation. Correct? So what all are we have made using product category equal to category, city, postal code, product name, region, segment, ship mode, subcategory. Got it? So obviously nulls will present. We have to exclude the null to show right information. Correct? So let's one more thing we should understand. Data blending is independent for each sheet. Data blending is independent for each sheet. How it is independent? If you look at in data blending one sheet, orders sample superstore is a primary data source, global sample superstore is a secondary data source. Means what? Order sample superstore from Excel sheet, this is acts as a left table. Global superstore will be acts as a right side table. When you're joining two tables based on a relationship with a common column, the first column what you are dragging from the source, which source you are dragging, that data source becomes a primary. If it is a primary, that will be shown with the blue color tick mark. Okay, the next column which you are pulling from the another source, that means that acts as a secondary. If you look at I have pulled product category. Product category is coming from the global superstore. That's what it is labeled as a light orange tick mark. Got it? So if you look at product cat, how many categories are there? Three categories, and there is one null. uh, let's pull categories. I18 in which one is null, and yeah, we can discuss about region. If you look at I'm dragging region from the orders sample superstore. Means what? When you're dragging the first column, the data source acts as a primary data source. And when I'm dragging region from the secondary source, to drag the region from the second source, what I have to do? I have to select the second data source, then select the region into the report. Okay. So what it is pulling? Region. Okay. I mean regions also same. Let's pull country or region. Canada under United States. Whereas comes to global superstore, market is a no country. Let's drag country into the report. We have to join. We have to link a maximum number of columns. So why we are getting this error? Mm. If you look at if you look at here, I'm using country from orders sample superstore. Accordingly, I'm pulling country from global superstore. So we have a number of countries in the global superstore. Sometimes this is one of the limitations in data blending. What is the limitation? Report shows asterisk mark, I mean star mark, when secondary data source returns multiple values to the single record. Single record of primary data source. Got it? So this report shows asterisk mark when secondary data source returns multiple values to the single value of primary data source. Single value of a primary data source. What is a single value? For example, this column is a primary. Obviously, for Canada, it is trying to return multiple records. When I pull everything, if you look at to overcome this issue, what we have to do? We have to link a maximum number of columns. So why it is returning blank? Only the because second data source is returning multiple records. How? Because we have two states, Canada and the United States. But the thing here, we have a number of states. By default, Tableau performs left outer join when you are performing data blending. Left means what? It is showing all the records from primary, common records from secondary. When it is returning common record, when we don't have common record, it has to show blank. So blank coming from how many? Multiple records. This is for United States. Similarly, United States also same. So it is having, so there is a blank column and also there is a United States. So both are linked to the United States. Got it? So to overcome this asterisk, what we need to do? We have to make a link with the maximum number of columns so that the respective values will be shown in the report. That's one thing. Okay, so let's country we have taken, right? Let's take the country from global superstore. If you look at these are the countries we have. So anyway, I'll filter out this null. I mean, their word which is having a null. I am excluding the null at source level, so obviously it will get reflected in all the sheets. So that is a data source filter. So obviously wherever you are using the filter being applied to all the worksheets. Got it? Now what I am trying to pull? I'm trying to pull country. If you look at this is returning asterisk. To overcome this, we have to link the columns. One is city I am linking. Okay. So if you look at Argentina and Australia, both are linked to United States because there might be a common city in both. I'm removing this. Okay. In blending relation, we missed one thing. Country, country or region. Hmm. So when you link country and country region, what is happening? United States joined with the United States, Canada joined with Canada. If you look at if you linking with category or some other name, obviously other countries will join with the countries as well because you are joining based on a category. Moreover, here we are not performing a join by default. It takes as a left outer join by default. Left outer. How I am saying left outer? Because if you look at when I'm dragging country from the global superstore, this is acting as a primary data source, and the next data source acts as a secondary. That's the reason here all the values from the primary data source being shown. Only the common record values being shown in the report from the secondary, and whatever it is not matching that returns null values. So when we don't have relevant data in secondary, it returns blank information. Okay. So moreover, what needs to understand here, when you are performing data blending, there might be a chance of getting null values. How? When a secondary data source does not have a common record with the primary source, then it returns null in the report. So we don't have Tajikistan, we don't have Taiwan, we don't have Syria. Likewise, we don't have most of the countries except two. That's what the second data source returning null for that record. Moreover, by default, I'm saying left outer join. Is it possible to perform inner join with the data blending? In data blending, we don't have any option to specify what type of join you want in the report, because here the report and I mean data from multiple sources getting blended into the sheet on basis of a relationship. When you are in the relationship, there is no joints need to be specified. Got it? We cannot specify the joints here. What we have to do? So to perform the inner join, right click on the secondary column, exclude the null values. Means what? This becomes inner join. By excluding null from secondary data source we can perform inner join. Okay, similarly go to sheet 5. Here if you look at the join is happening based on subcategories, based on categories, based on product names, based on regions, based on segment, based on ship mode. So I have to break all of these, even country postal code. So there might be a postal code is common for cities. That is a reason it was misaligned. Okay, if you look at the country or region is a column coming from orders sample superstore. We have only two countries information in orders sample, that is Canada and the United States, correct? When you are pulling similar column from the global superstore, it is returning only common records. There are extra values, but those all are got eliminated because so the join itself it's a left outer join. Left means what? All the records from left table, common records from right table. All the records already extracted, only common records from right table being extracted here. Okay, so this is a left outer join between a global and orders. But the thing you should understand the difference between 25 and 26. What is happening? See, by excluding the null from secondary source, I am considering this as an inner join. Whereas comes to sheet 25, I am considering this as a right outer join. Why I am right outer join? Vice versa. Sheet 26 is a inner join. Duplicate. Remove this filter. This is a left outer join. By default, left outer join get performed. Obviously, null will return. So when I am excluding the null, it becomes a inner join. When you swap the data sources, left to right, right to left. Okay, here global is left, orders is right. Here orders is right. I mean orders is left, global is right. Means what? It is swapped. So obviously we can call this as a right outer. See, both are left outer only. But the thing you should understand, comparing with this, what left outer returns? All the records from primary, common records from secondary. Similarly, if you make right outer, what happens? All the records from secondary, common records from primary. All the records from secondary, common records from primary. I'm swapping the data source. Here global is a primary data source. Here orders is a primary. When you are changing the data source primary to secondary and secondary to primary, what happens? As per understanding, it default performs left outer only. But the thing, when you compare these two, this you can consider as a left outer, this you can consider as a right outer. Otherwise you can consider this as a left outer, you can consider this as a right outer, anything is fine. But when we are working to perform left outer, right outer based on the requirement, you can use like this. By swapping primary to secondary and vice versa, we can perform left outer under in a data blending. Got it? Full outer is not possible. Okay, so like this the way we cannot use a full outer join in a data blending. Okay, asterisk mark mm, data blending. So let's plan category. Okay, here also let's use a product category. It calculated field. I'm writing a fixed LOD. mm, Max of you can use columns from secondary as well. Argument to max an aggregated function is already an aggregation. If you look at what is the error here. For example, I am trying to extract okay latest data from secondary data source. I'm aligning that date with the primary data source category. Got my point? So I'm writing LOD on secondary data source. Okay, so when I'm creating a calculated field in the primary, I'm taking a reference from secondary data source column. So when I'm using that, what is happening? Argument to max an aggregate function is already aggregate. What is an aggregate? ATTR is a it's a table calculation. So let me remove this. That's what it is showing, aggregated function. Level of detail expression could not contain table calculations or the ATTR function. Okay, then move it. What is error? Result of level of detail expression must be an aggregator. So I'm using max of order data from secondary source. What it is returning now? And here all fields in level of detail expression must come from the same data source. So you cannot perform LODs on a secondary data source aggregated columns. Got it? So LODs does not support to perform on secondary data source columns. product categories. Okay.
So is there any other way to do that, or
So I have linked maximum number of columns. Still, it is returning the same error. So we cannot create LODs on second data source columns. So we have to find some alternate for that. Just check it in Google how we can achieve that. Okay. One more thing. Moreover, you should understand here the data joining is performing on aggregated data. I mean report level data. So moreover here you should understand we are making just relationship. Okay, we are not physically joining any table. When you physically join any table, what happens? We know to perform the join between two tables, right? Left outer, right outer, and full outer. By opening this here, you can perform other tables, right? That we discussed: people table, returns table, correct? Left outer, right outer, and full outer joins. So that is a physical join. Physical join creates a resulted data based on the join whatever you performed in the report. Got my point? But in data blending, based on the relationship, by default Tableau performs a join with the left outer. So using some workarounds, you can use you can make this as a inner join or a right outer or something like that. You can make it. That is possible. Got it? So like this the way we can able to write a calculations. This is about data blending. So from 10.5 version onwards, Tableau introduced a cross database join option. Cross database join options. For example, orders sample superstore is a primary source. When you have data in other type of data source, you can use cross database join. How to perform cross database join? Let's select add option. So if you select add from here, this data source acts as a new data source. If you look at like this the way, you can see the data sources. But the thing, when you are adding the data source into the connections pane, to get CSV data from CSV file, we have to select an option text file. Correct? This is a global superstore. This is a CSV file data. This is a global superstore data. Let's open the what is this? This table. Open the layout. Okay. This is a physical layout. If you want to perform the join, you have to open the physical layout, then drag this sample superstore global superstore to the physical container. By default it performs inner as a default join, but it takes based on a common column. You can define columns here. So if you, on which column basis you want to perform, you can perform based on the requirement. So for now I have given reference of 3 columns. You can add any column here. Okay. So you can also create a column based on the formulas, and accordingly you can also perform the join here. Okay. So these are the joins we can perform: inner join, left outer, right outer, full outer. What do you want, you can select that join. So when a join is performed, it creates a data set, right? It is a physical data set. So obviously what happens here, joining happening on disaggregated data, on raw data. So the count get increased, and the data becomes a huge volume, correct? So when you are going to the report, this is sample superstore is a data set joined with a global superstore. That's what, if you look at tables data is from two different sources, two tables: global superstore CSV and orders. Below are the calculated fields. Obviously calculated fields will be commonly used in both the data, I mean in this data source, for both the tables. Okay. If you expand the global superstore, these are the columns. If you expand orders, these are the columns. How do you want to use, you can use it, which product, which sales you want. Okay, you can use into the report. Okay. Okay. So like this, the way we can create a cross database join, which is option introduced from 10.5, because there are a lot of limitations with the data blending. Data blending gives high performance. Why it is gives high performance? Because data blending made a relationships. Using the relationships, the performance is high. Okay. So we can perform a relationship between two different granular information. If you look at global superstore and sample superstore, both are having same level of data: country level, street, region, order date, category, subcategory, and product name. If global superstore is having only product name level information, then those two are the two different granular informations, correct? Order superstore having category level. Let's assume global superstore will have the data at a product level. So what is the use? When you perform the physical join, obviously each product will joined with the category. So what happens, data becomes huge, there is a lot of duplication. When you make a relationship, what happens, and we don't see such I mean such duplications. We can reduce redundancy. And also in the relationship, if you look at here in the report, in the data blending, the data is joining it after aggregation. Here at report level only it is getting joined. That is a benefit with data blending, but data blending has limitations. It won't create a data set, it's complete logical. Whereas comes to the physical joins, it creates a data set, right? If you performed a inner join between these two tables, global superstore and sample superstore, obviously the resultant will create one data set. This is the below is a data set. This is embedded with the workbook. Sometimes it becomes huge based on the volume of the data, based on the join happened. It increases a count of records. So like this the way data blending works. So we have the relationship concept, we will discuss tomorrow or day after tomorrow class. Got it? So this is about data blending and cross database join. From which version? From 10.5 can perform physical joins between multiple data sources. Okay, so that is possible. In data blending, one of the limitation, null values also appear. Okay, so if you have more number of columns linked with a primary, then data blending is very good. Okay, so performance wise also data blending is very good. So like this the way we can perform the data blending.